Hello engineers, welcome back. In the previous video, we learned about binary search trees in theory. In this video, let's code it in C++ and see how the operations will look like. Okay, I hope you're ready. Let's get started. So in the previous video, we saw what are binary search trees and the structure of a binary search tree. Just a quick recap. So binary search tree is a binary tree, but in a sorted way. So for every node, the left children will always be lesser than the parent and the right children will always be greater than the parent. Okay, that's all we need to know about binary search trees. And then we saw the operations, how to insert, how to remove, how to display, and how to search. Right? So it's time to code it. Let's go to our VS Code. So I've created a new file called binary search trees, and then I've created the base template. Now we can get started. So what do we need? First, we will need our node. Node will have public properties, which will be left, right, and a value. There will also be a constructor which will take in a value, and this value will be initialized. And let's also point our children to null. And that's it. So this will be our base node. Every single node will be having this structure. Now let's create the binary search tree, BST. So what do we need? We will have a private node which will be root, and let's have a constructor which will just initialize the root to null. Okay, so this will be our binary search tree. So how do we create it? We simply say bst. So this is the class name, this is the object name. Okay, next let's see what we can do. First, let's do insert. Let's create our first public method. Let's do insert. So insert will have a return type of void, and then it will take in a value, and let's try to create the same tree like we have discussed in the previous video: 100, 90, 110, 80, 95, 93. Okay, so what is our strategy for insert? So for insert, if it's an empty tree, we can directly make it the root node, right? So let's do that. If root equal to null ptr, then root can be the new node, and return. So that is done. Now secondly, if we want to add a new child after the root node, we have to check whether the value is less than the parent or greater than the parent. Let's say we are inserting 90. 90 is less than the parent, so we have to go to the left side of the tree and insert it there. If it's greater, we have to go to the right side of the tree. So first we need to find the position where we will fit it. So in other words, we can say that we are trying to find the parent of the node which will carry this child. For example, if I'm inserting 93, I need to go through the tree and find 95. Once I find 95, I know where to place 93, right? So first we are trying to find the parent. Okay, so let's get that. So let's get parent, and we will send our value so that we can find our position. So this will be a private method, helper method for us, which will return a node pointer, and this is get parent. This will take in the value. So what is the strategy here? So to get the parent, we need to traverse through this tree one step at a time, one level at a time, and we have to keep going left or right. So let's create a current pointer and let's point it to root, and the parent of root will be null ptr because there is no parent for the root. So how do we traverse? First, Let's create a loop. While current not equal to null ptr, we need to go either left or right depending on the value. So if given value is less than current value, then we know that we need to go left. So current will become current arrow left. Similarly, else case, else if value is greater than current arrow value, then we need to go right. So current will become current arrow right. The third case, if there is a third case, which means if they've given a value which is already there in the tree, then we have to reject it. So we will simply say node already exists in tree, and we will simply return null pointer. If we are returning null pointer, it means that node is already existing. Otherwise, we will return the proper parent. Right? So we are updating current, but we also need to update the parent, which we will return at the end. So at every step, we will update the parent. Parent equal to current. We will repeat it here as well. So if value is less than current arrow value, let's say we are at 100 and we are inserting let's say 93. So we need to go left first. When we go left, 90 is the new current and 100 is the parent, right? And when we go right, 95 is the new current and 90 is the parent. So that is what this loop is doing. Okay. So all this is done. Finally, we can return our parent. Okay. So we got our parent. Now let's do a check. If parent equal to null, which means node is already existing, so we can simply return from here. Otherwise, we have found our 95. So at this point, we will check whether to put it on the left side or right side. So if parent arrow value, we can do it like this. If our given value is less than parent arrow value, then we'll put it to the left side. Parent arrow left equal to new node. We'll create a new node with the given value and put it there. Otherwise, we will put it to the right side. Parent arrow right equal to new node. Right? Simple. So that will be our insert method. So let's test this. So to test this, let's also create our display method. So we will say void display, and let's implement level order search. You can implement the other methods by watching the previous videos. I've already explained how to implement the in order, post order, traversals in the previous video, in order, pre-order, post order. In this one, we will do level order. Okay. So let's do it. Level order. Let's put it in a new line. Let's say level order print or display. So let's call our method level order. Okay, and after that, let's do end line again, just for our easy printing. Now let's create our method. So this will again be a private helper method, which is called level order, which will not return anything. Level order, and because this is a private method, it already has access to the root, so we don't need to pass root again. So what do we need for level order printing? We need to go one level at a time. For this, we will be using a queue. So let's create a queue. Queue of node pointers, and the first element in the queue will be our root. So here we can do one more check. If the root is empty, no need to go inside the level order method as well. So we can say if root equal to empty null ptr, then we can simply say tree is empty, and return, right? So this is done. And now here we can safely assume that root is having a value. Now for level order, we will print it, and if there are any children, we will add it to the queue. So while queue is not empty, what do we need? We need to get the first element out first. So let's do that. Front equal to queue dot front. So our first element is out. Let's print it. Front arrow value. Let's give some space. And then we can pop it. It is done. Now, if there are any children, we will add it to the queue. If front arrow left is not equal to null ptr, then queue dot push front arrow left. We will do the same thing for right. If front arrow right not equal to null ptr, then we will say queue dot push front arrow right. So this will be our level order display. Okay, so let's test it. So let's do our inserts. Let's close all this. So bst dot insert first 100. What else? 100, 90, 110, 80, 95, 93. 100, 90, 110, 85, 95, and 93. 80, 95, 93. Fine. And then let's call our display method. So what do we need as output? Output should be like this, right? 100, 90, 110, 80, 95, then 93. Okay. So let's run and see. Okay, so our print order is displayed 100, 90, 110, 85, 95, 93. 100, 90, 110, 85, 95, 93. So fine, our insert method is working just fine. Okay. Okay, now let's also implement search method, which will take in a value. And what do we need? First, let's do a root check. If root is empty, we don't need to search anything. We can simply return from here. We can say tree is empty and return. Otherwise, how do we search? So this is not a level order search. We can use the property that the tree is sorted, and we can smartly do binary search here, because we know that the tree is sorted. We know that if an element exists, it can either be on the left side of the parent or the right side of the parent, right? So in our example, if I want to search for 93, first I will start at 100. Then I know that 93 is less than 100, so I will only find it in the left tree, right? And if it's greater than 100, I will only find it in the right tree. So we'll use that logic. So let's see. So first let's do a current pointer, which is pointing to root, right? So we need to change the current and keep traversing through the tree. So while current not equal to null ptr, we can keep going. First, we will check if the value exists. We can simply say value is found, and we can return from here. So if given value is equal to current arrow value, then we will say cout node exists, and we can return from here. Otherwise, if value is less than current arrow value, then what do we need to do? We will change our current. Current will become current arrow left. Okay. Else, this is the third case, current will become current arrow right. Okay, after all the search, if we are still in the loop, if we are still in this function, which means that it did not go into the if condition, which means our node is not there in the tree. So we can simply say node not found in the tree and return. Okay, so that will be our search. So let's call it. Let's see if our search is working. Let's do a cout bst.search, and let's search for 100, which is a known element. Let's search for 90, which is also a known element, and then let's search for something that doesn't exist. Let's search for 10. Okay, actually let's put an endl here as well. Okay, so let's see. Spelling error. Okay, so we have node exists, and node not found in the tree. Okay, so our search is working fine. Let's also print the value so that it is more clear. Value exists. Okay, 100 exists, 90 exists, and 10 not found in the tree. So our search operation is also working fine. Okay, so let's pause the video here because this video is getting long. We still have to do remove method, so we will continue that in the next video. Okay, so thank you so much for watching, guys. If you have any questions so far, you can definitely ask me. I will quickly see you in the next video. Thank you. Cheers.